Hey folks, welcome back to the channel. Appreciate everybody watching. This is part 9 of the Tesla EV conversion of the 74 Super Beetle convertible here. And this is going to be the 88th video that I have on my channel. So if you'd like, check out the playlist. And I've got solar projects galore on there. I've got diesel projects. I've got e-bikes. All of my videos are teaching videos. So everything from welding to wiring to whatever is in the videos. But check out the playlist and please like and share, subscribe. Last video I covered all the nerve system, the major control system located in that box. That's done. And now I have the BMS that I mounted. So I've built a platform that's going to go underneath the driver's seat. I wanted to keep the front trunk of the car totally empty. I've seen a lot of videos where folks are mounting all the DC chargers, everything in the front, but I wanted to keep everything out of sight. When you look at this car, you're not going to know that it's even electric, hopefully. But anyway, I had all this room underneath the driver's seat and decided to get a piece of steel, cut it, and bend it on my bender. So the Orion BMS mounted real nice underneath here on the platform. I've got it right there. The thing I like about Orion is it is auto balancing of all the cells, so it constantly keeps all the cells optimized for their charge rate and temperature monitoring and all that good stuff. And then since I have 6 battery modules, I have 2 thermistors per module, so that's 246 times 2 battery packs. That's 12 thermistors. The standard Orion BMS only comes with 8, so I went to a thermistor expansion and then ran all of my thermistors into this box. This unit's going to be powered and also be on the CAN bus, but I have my loom all done, running to the back battery pack up here behind the seat, and that'll plug in there. And then I have my front one done, and that'll plug into the port on the other side of the BMS here. The neat thing about the Volkswagen is I had this air channel, which I'm not using because I have my heater over there now. So this is abandoned, but it gave me a nice pathway to come right out of here, go into the airway for the heater, and then come up through the A-pillar and into the front trunk. So I just fed up the 2 lines. This is the BMS, all the cell connections for the voltage, and then this is my thermistor, and everything came right up here, right into the battery module, which I'm building on the bench. Here's my high voltage lines. I don't think I showed that in a previous video, but all 3 lines just come right underneath where the old gas tank used to be. So the 2 orange are the high voltage, and then the black cable there is going to the wall charger on the wall, and the J1772 charge port. So here's my front battery case all assembled. I slid the batteries in like drawers on the drawer sliders that I made. You can see the bus bar here that I picked up from App Revolt. And then also, I believe Zero EV has them. All the links are in the description for their websites for the suppliers I used. But real heavy bus bar. But what's nice is made for the Tesla S or X battery. And I'm tying positive to negative, and so on. So that'll give me the total voltage in series. And then what's nice too is they also sell these little angle adapters. So they go up in there like that. And then the one on the bottom right in there. And that gives me an easy termination for my lug. So when I go to wire up the fuse, which I have the fuse mount here that I'll bolt down, that I welded a plate onto the main carriage here. So this is going to mount the fuse. This is a fuse from EV West, 600 amp, pretty healthy little unit here. And that's going to go on top there and bolt in. So next thing is I need to crimp up a 2-aught wire from here to here. I'm grounding my fuse is on my negative side, so I'm going to have a lug made from here, cable 2-aught over to here, and then from here up to my quick connect Amphenol connector. But you can see the loom's all made. That was a really chore to get all these Molex connectors wired into the aftermarket board that I use to interface into the Tesla batteries. But they have all these little pins on a 22 gauge wire that have to be crimped and soldered, and it's quite the task. So you definitely need a magnifying glass to do this. But you see, here's my boards, and here's my wiring. This is looking down on a Molex connector. So directly down, I have my cell 1, 2, 3, 4, 5, and 6. Up here's my negative wire that goes to the BMS. And then these are my thermistors, T1, T2, T1, T2. But what's tricky is wiring these to be compatible with the BMS. So again, I like the Orion BMS. That's what I chose to use on this project. But what you do is go on to Orion.com and go to the BMS2, which is what I have. And they have a configurator that generates basically a block diagram of the cell wiring configuration here. So you go online, you put how many modules you have, how many cells you're doing, where the split is between the front pack and rear pack. It asks you all that stuff. And then you hit the magical button, and then this is generated, and then save this, and this is going to be your block diagram for wiring up all the looms. But the tricky thing is I haven't seen this on YouTube anywhere. I searched high and low. Orion doesn't explain it on how this exactly works. They just give you this and go figure it out. But so if you're doing this, it's going to save you some time by watching this part of the video. So Orion works in groups of 12 cells. The Tesla batteries are in a group of 6 cells. So what I need to do is split this, because I'm going to have these all in series to get my total voltage. But what I need to do is put a ground wire here on the first Molex connector, right there, negative. And then if I were to take a voltmeter and go across, keep on negative on common, and then if I go to pin 1, say if it's 4 volts, not totally charged, but say if it's 4 volts, then if I go to pin number 2, that should be reading 8 volts, and then 12, and so on, all the way up to 6 times 4, which would be 24 volts. So when I go to negative to pin number 6, it should be 24 volts. What the challenge is, this is 6 cells, and the Orion works in a group of 12. So when I go to my second module here, if I were to put a ground wire on this, it would be another reference ground, and it would start off again 4 volts, 8 volts, all the way up to 24 volts, right? But the challenge is it works in groups modules, 12 cells, so I don't use the negative on the second module. Okay, so when I have the BMS, when I have the total system strapped together with this bus bar, then when I take my voltage reading, I'm going to hold my common on my meter on this negative here, and I'm going to read all the way up to 24 volts as before. I'll stay on that negative, and then when I go to cell number 1 up here, then it's going to be 24 plus 4 volts, that's 28 volts, and so on, all the way up to 12 times 4, which is 48 volts. So that wasn't explained anywhere on Orion's website. I didn't read any documentation. I didn't see any YouTube videos, so this might save you a lot of time. Okay, now when I go to the third group of 6 cells, the third module I have in here for the Tesla module, it shows me now that I need to add a ground wire. So now I do put a ground up here on this Molex connector, and then I start over again. 4 volts, 8 volts, all the way up to 6 times 4 volts, 24 volts for this battery module. Now the challenge is it's looking for another 6 cells on group number 2 here, which I don't have. So what it shows you in the diagram, and again I haven't seen this explained anywhere, is what you do is you strap all the other wires together. So 18, 19, 20, 21, 22, 23, and 24, you tie all those together and make that pin 18. So the BMS basically sees the voltage on 18, which would be the total voltage, and then it also sees the same voltage on the remaining wires, and that's how you complete the other 6 cells that don't exist on group number 2. Now if I had a 4th battery module on here, I would repeat the same thing as I did for group 1 here. And then for my rear battery pack, I continue the same process for back there, and that's going to be group 4 and group 5. So I repeat the same process over again one more time. And this plug connector is one plug connector that'll go in like I showed for the front, and then the other connector goes into the BMS unit will be the rear. But I just repeat the process for the rear battery pack and I'm good to go. This was tricky to figure this out, but maybe this will save you some time. So moving on, next thing I need to do is crimp up some cables and get this put together, and I'm going to be in pretty good shape, and then I can reinstall it back in the car. All right, the battery boxes are in. Front battery box done, ready to plug in my high voltage onto my Amphenol Quick Connects, boom, like that. And then I've got the rear battery box installed, and made it real nice having my lift up here to go up and down since it's convertible, like I said earlier in the video. Nice just to drop it in the top instead of trying to muscle 200 pounds back behind the seat. I did put the seat in, see how it would look, and fits perfect. And then again, my high voltage connector is ready to connect up here. So the next thing is, I've got the motor controller off the motor here on the bench, ready to put the motor in. I did get my clutch in finally, and that is a Kennedy Stage 2, which will handle more torque, pressure plate. And the disc inside is a cush lock. EV West does a really nice light and flywheel that'll just basically zero vibration, and then also the adapter from EV West. So I'm ready to go ahead and lift it up with my hoist and install it. I do have a new throw-out bearing ready to go, and new motor mounts. Everything should fit. All right, some more progress on the Super Beetle Tesla conversion here. Looking really good. Getting to the back here, I got the motor back in, and worked out really well. And it's a whole lot easier than the original Volkswagen motor, trying to muscle a 300-pound motor back in here. So, but I'm also fabricating up the side panels. What I did is made a template out of just some poster board from local hobby shop, and cut it so that's the left side, and then flip it over and it's symmetrical, so the right side also is the same template. And then I transferred that to steel, and I have a 1-inch lip down on here to give this rigidity across here, and I'll weld in like a little mounting tab here and one in the back corner. But just roughing stuff in right now, looking really good. And then this is going to be the location for the radiator and the fans that'll come on with a key and just blow constant, and I'll circulate water from the motor controller ports here with a little pump. There's the little pump, and the pump will go back here in the corner. And then I have a fluid reservoir that'll mount up in the corner like this, and that'll work out really good, so I can keep my radiator fluid, and that'll complete the cooling. But I can't really drive it a distance until I get cooling on that motor controller inverter. And then over on this side, I'll mount the DC to DC converter, which again is the equivalent of a gas engine alternator. But I've got the CAN bus already built, ready to go. Twisted pair. And if you look up here on the board, so what I have is a lot of taps off of it. So what you do is do a twisted pair, just put it on a hand drill, spin wires together. I used 18 gauge wire. In this case, I used green for low CAN bus and the yellow for high CAN bus. And then at the end, you put your terminating resistors, 120 ohm on each end to prevent reflection on the network. So basically, this is a network. Controller area network, CAN bus. So I have my taps here for my motor controller. I have a tap for the Elcon charger, the other tap for the second Elcon charger, and then I have the BMS here, which is going to communicate to the chargers and the motor controller, the Orion BMS, and then I have the thermistor expansion, which also communicates on the CAN bus, and then I have a couple taps here for my laptop to plug into so I can program, and I'll show you how to program the motor controller here in a minute with a serial port, and then also go on to the CAN bus and program the BMS to recognize the Elcon chargers and use the profile wizard, which is really cool. So you definitely, if you're building one of these, you want to see this. Here's the CAN bus, all done, ready to go. And I use Deutsch connectors. I'll put a link in the description. These are great. These are a 2-pin. I also have 4-pin, 6-pin Deutsch connectors. And I just plug in my devices. Here's the Elcon charger plugged into the Deutsch connector off the tap off of the CAN bus. And then here on the end, there's actually a 120 ohm resistor in there soldered in, and then I shrink wrapped everything. But all the pins too, I do like soldering all the pins on the Deutsch connectors. It makes them hold up really well. Got the BMS in and wired. We'll see if we can get a shot of this. And see, there's the BMS there, all wired, and then over there on the left is the thermistor expansion. And got some of the wires tidied up and looking pretty good. But so next, let's commission the motor, and I'll show you the Smart View software from Netgain, who was really great to work with. Appreciate Hunter talking me through some of the setup. So let's go show the setup, which I haven't seen on YouTube, and then we'll go into the CAN bus and then show the setup, how easy the Orion is to program. All right, so I have everything wired on the car, just finishing up fabrication, and it's looking really good here. So I'll get that done later. But I want to cover something that I haven't seen on YouTube anywhere, and that's how to finally program the different devices in the car. I've searched hundreds of YouTube videos. There's none out there that I found. If you found one, please leave it in the comments. This is probably the most important step, is actually programming the devices. So there are 3 areas of programming that need to be done when you first commission the car, and that is the Xantrex controller that I'm using up there. You may be using something else, but I found this is a really neat way of doing it. How to program the motor controller for the first time and commission the motor. Crucial step, or else you're not going to be going down the road. And then important step 2 is programming the BMS, the Orion BMS. So to start off with the Xantrex controller, this is the gauge. It's going to be on the dash. It's the only gauge I'm going to have. I'm going to keep this car simple, without displays showing cell voltages and all the other stuff that you can do if you want to geek out and connect to the CAN bus and have a display and all that fun stuff. But this is basically a display. It shows that I'm 100% right now. And then when I plug in the charger, the screen lights up. So if you have any doubt if the car's charging or not, just look at the screen. If it lights up, it'll be charging. So there's my 100%. And then if I scroll through, I'm at 146.2 volts and so on. And just a really nice device to use. And that connects to the shunt that I showed you in a previous video. And then I have 2 wires coming out here. And this is an internal relay that the unit has inside it. It's normally open, so you go into the function when you program it. And for all the programming, I'll put a link to Michael at EV West's video that'll take you through all the function steps. But you go in, you set up what shunt you have, what prescaler you're using. In this case, it's a 1 to 5. And then on the relay, you want to put normally closed. From the BMS for the pilot and proximity control for the wall charger or the public charger, you have 2 wires. One's a white wire with a brown stripe and a white wire with the orange stripe. The white wire with the orange stripe is the pilot wire, and then the other is the proximity. So what I'm doing is I have my proximity wire going directly to the pin on the J1772 plug. That'll take the 12 volt signal from the wall charger and tell it that the car is connected. And then my pilot I have connected through in series with the internal relay here. So what this is a fail-safe. So if for some reason the BMS messes up, CAN bus signal gets corrupted going to the Elcon chargers, then this will be set at a voltage that if it gets maybe 1.5 volts above where the BMS should be, then this is like a fail-safe. It'll open up that relay and turn off the wall charger or the public charger. So a very easy way to doing it. But again, I'll put Michael's link in the description on how to program that. It takes you maybe 5 minutes, and then you're done with that. The next item you want to do is commission the motor. So the motor control inverter is up here at the top, and there is a serial connection, so you unscrew a little cap, put it in the little receiver up here. But this is a serial cable, DB9 connector, 9-pin connector, that goes and then connects to the USB port on my laptop. So what you want to do next is to go to the website, and I'll put the link in the description. This is go-ev.com. This is Netgain's website, and download the software that you need. Okay, so there's 3 components that you need. You need the Smart View software. Just go ahead and download that. This has to be a Windows box that you're loading this onto. They don't support iOS, Mac stuff. No big deal. Zip folder, unzip it, install it. Pretty self-explanatory. And then you have a clone file that you will need to initialize the controller that you need to upload into the controller. So you want to download that and have that at a location. And then you want the driver. You need the USB driver to communicate to the 9-pin connector. So you want to install that first, install the driver, come up, get your clone file, and then download your Smart View software and get it running. There are 2 different models of the Hyper 9. One's the high voltage and one's the regular voltage. I have the high voltage, which has more horsepower, more torque. So in this case, I downloaded my HV, stands for high voltage. All right, so the key has to be on the car. The high voltage has to be on a motor controller. You need that to be able to connect to this. So I have a connection. You want to get the clone file, and then you want to upload the clone file. You want to go into configure, and then you want to go to the motor controller, hit that, and then down at the bottom of the screen it's going to say spin motor. So I already did this. It's going to spin the motor, and what it's going to do is synchronize the rotor position sensor that I pre-wired up in a previous video to detect the position of the rotor as it's spinning. So it'll run the motor for maybe a minute. You want to make sure there's absolutely no resistance. Don't have it in gear, have it in neutral. Make sure that there's no resistance on your clutch, your throw rod bearing, your pressure plate, because if it detects a little bit of resistance, it's going to basically fail. All right, so I already spun the motor. It's commissioned. And then if I go back to the home button up the top here, I can do my monitor, my manage, and diagnose, that sort of thing. So if I go to my monitor screen, this is a really cool software package. And if you have any questions at all, Netgain support over the phone, you can actually talk to a human, other than other sites where you just have to email people and hope they get back to you. But special thanks to Hunter up there. Netgain is a family-owned business. They're shipping these motors, these permanent magnet synchronous reluctance motors, all over the world. Just a ton of them going out every month, but their support's phenomenal. Call them up. Hunter helped me set a lot of this up, so thanks, Hunter. But I'm into the monitor screen, and you can see here's my traction right now is enabled, so I can put it into gear. If I'm plugged in, I have a relay that'll kick this out, and you can't move the car if the car is plugged in, etc. And then my forward and my reverse here, my torque limit and that sort of thing. But what's really cool is these will light up. So I'm going to go ahead and put the forward switch on, and you can see the forward lights up, and then I'll go into neutral. There's my reverse. So once you wire this, you can verify all your contacts are working without even starting the motor up and running. So now I'm in reverse, and then if I put in my profile 1 and profile 2, which I have set up for my regen braking levels, I'll throw the regen on. So I'm forward, and then I'll put a low level regen on, and then it's lighting up down here. So that's profile 2, and then I'll set up profile 3, which is my highest level of regen braking. This software is really cool, pretty neat. Also, my throttle, I can go in and set up my throttle, which I'm using the Prius pedal, and it'll check the resistance, make sure you're throttling up all the way. So once you start up, you want to update the clone file, and then also you need to get the latest copy of the firmware and then install it, and that's easy to do. But if you have any questions, again, just put a call into Netgain. So one of the first things you want to do is get a firmware update, and you can click on here. Here's my latest firmware update, and then you can browse after you download it from the website, install it. It's pretty self-explanatory. And then if you go into your clone file, this is basically your backup of your database that you have in there. So once you have your clone file, you hit this and it's going to upload the clone file parameters into the controller. And then as you make changes, then you want to hit the other direction and take the clone file and save it to disk and do a backup and put it on maybe a thumb drive. And then go into system configuration. Here's a data sheet. Here's my voltage, my nominal voltage, and I'm going to see on my battery pack and so on. You could set all these up. And then there's my battery, my low reset threshold, it shows a nice little graph of the battery. Right now I'm pretty full. And then your protection, maximum controller current limit versus battery voltage and so on. You can add and adjust these curves. But again, if you are like lost with all this stuff, just give Netgain a call and they're very willing to help. Once everything's done, you're in good shape to, go ahead and put it up on jacks, put it in neutral, and then try your forward, press the throttle pedal, and then also check reverse. Once this is all set up, you can go ahead and try the car, but have it jacked up in the air, have the wheels off the ground in neutral. Go ahead and put it maybe in second or third and hit the forward button and then press down the accelerator pedal. So let's go ahead and try that. Here we go. Press forward, reverse. All right, so we have the car running now, functional. The motor controller's programmed. I have my dash gauge showing voltage and doing all that good stuff. Next thing is to program the charging system. So I'm using the Orion BMS. The advantage of this that I found is that it does automatic balancing of all the cells within 1/10 of a volt, which is really cool, and I'll show you that in a minute. The other stuff that I looked at, like dilithium and stuff, it's like a step back into the 90s where I got to use putty. I'm into a green monitor doing command line prompts and stuff like that. I didn't want to go that route, and I didn't want to manually have to balance the battery, so this is full automatic. But there are a couple steps that you need to do, and I'll take you through that. There are 3 power supplies that are going on to the BMS. Key on power goes into the BMS. And then you have all power all the time, just connected directly to the battery. And then you have charge power. So when you're plugged in, it's actually providing power through a transformer to go ahead and provide power to the BMS. And then also, in my case, a thermistor expansion, which I'll cover. So what I did here is I added a second power supply, another power supply on here, just a computer power supply. I think it's like a 10 watt wired into the 240 volt. It also runs on 120 volt, depending if I'm plugged into a level 1 or level 2 charger. In this case, I have a level 2 charger on the wall. That's good for 240 volts. If I have another charger, like a portable one, I can plug it into a regular wall socket, and it would be a level 1. So my Elcon chargers here, 6.6 kilowatt total, will run on 240 or 120. Same thing with my little transformer. So when I plug in, I get power coming over into this connection here, powers my Elcons, and then also powers up this small power supply to have charge power onto the BMS. The BMS software, the Orion BMS software, is up and running. And the first thing I want to do is go over to the profile wizard right here. And this is cool too. I've never seen this in any other software that I've looked at, but it has a profile setup wizard. So I'm going to tell it the battery type. Connecting the BMS is recommended. All right, so I'm going to connect up to the BMS right now. Also a note, out of the box, the baud rate is 500 kbit baud rate for the thermistor expansion and also the BMS controller. In this case, I'm using Elcon chargers that I need to talk to over the BMS. So those are hardwired at 250 kbits. Those are hardwired at 250 k baud, and I need to back down my BMS. So everything on the CAN bus is at 250. So I need to change this. So again, default would be 500. I'm going to change that to 250 and then connect up. Same thing with my thermistor expansion. I have to go in and change that to 250 k baud also. So everything's cool. Go ahead and connect up. So now I'm connected, and it says, do I want to download existing profile from the BMS before I start changing anything? In this case, I'm going to say no. But the profile wizard, I'm going to go into that now. And it's going to say start with default profile. In this case, you would start with that for the first time. I already have a profile in here, so I'm not going to do that one. But what's really cool is I have a drop down for my battery types here. In this case, I'm using Tesla Model S batteries, and they're 5.3 kilowatt. Then you have a complete drop down list. Your Samsung batteries, your Winston batteries, Voltronics, Tesla, Sony, just a ton of batteries in here. In this case, I have the 5.3 Tesla S batteries, so yeah, I'm going to say that one. And my current sensor that came with the BMS, it's like a little donut ring that went over one of the power lines. I have a 500 amp in there. And then cells in parallel. This is really cool. So I have just all my batteries in series, so I'm going to choose one. But if I had two strings of batteries in parallel, then I could add, as many as I want. Just change that. And cells in a series, configure cells. I have 36 cells. And here's all of my cells that I have right now. So I have 6 Tesla S battery modules that have 3 cells per module, so total. I have 6 cells per module, and I have 3 modules in the front, 3 modules in the back, so 6 times 6 would be 36. So right there, then you hit the next button, just takes you through this stuff. Current thermistors, I don't have any of the 8 thermistors that are on the BMS unit itself connected, so I'm going to uncheck all those boxes. My relay settings, enable charger, safety output, this is pretty much default stuff, and enable my 1772 charger, and that will connect up basically the pilot in proximity to the white wire with orange stripe and white wire with a brown stripe. I think it's pin 12 and 13 on the BMS, so that's enabled. Yes, I have that. And then enable CAN bus support valve for chargers. In this case, I have the Elcon chargers. And they're just updated all the CAN messages. And then I also have the Netgain down here. Motor controllers, Netgain, so I'll check that one off. Hit OK. And I don't have any of this other stuff, so then I'll just say finish. And it's automatically configuring everything to what my profile is. So I don't have to go into command prompts and type in all this stuff through software application called Putty. And it just makes it so simple to fire this thing up. So I got the BMS from Amp Revolt back in Pennsylvania, in Lancaster, PA, if you say it right. And Brandon talked me through this when I first bought it. And he said basically how simple this is. You need to try it out. And he is absolutely right. So thanks, Brandon. So again, the links are in the description for all the suppliers I use for all this stuff. But Amp Revolt is where the BMS came from. Okay, so I'm going to disconnect. I don't want to change anything. The cool thing is, though, is once you're up and running, I can go live text data. And I can go into like live cell data. And there's all my cell voltages right now that I'm reading off the BMS. And again, this auto balances all the cells. and I've never seen this on a YouTube either. So here's all my 36 cells, all the voltages. You see them changing. They're all within 1/10 of a volt of each other, all balanced out or so. And then if I were to plug in the charger right now, which I'll do, you'll see some of these cells turn to red because they're balancing. Okay, you can see now that I have cell 7, 8, 9, and 10. They're in red, so they're balancing with the other ones as I'm charging. And this is so cool. I get excited about little things, but this is really cool in the software. You can actually see this happening. And then if I were to unplug my chargers right now, and again, I have the 2 Elcon chargers fired up, so these cells are balancing themselves for maximum efficiency. So I'm going to go ahead and unplug the charger right now, let it settle down, and you can see that it'll automatically balance the cells and shut off. So I'm unplugged from the wall charger, and the cell should balance here in a little bit, and then the red will go out and everything will just be stabilized. And there you have it. The cells are all automatically balanced. Very cool. But let's go back to the battery profile, and then you could see where I'm set up here, my cell settings. Here's my maximum voltage that came from the profile wizard. Right now I don't want to go over 4.150 volts. So it's basically taking the total voltage that the cell can take, the Tesla battery can take, and then taking it, I think, times a factor of 0.990%. So you never want to charge Tesla batteries up all the way, and that's how they get so much life out of the Teslas that are going down the road, is they don't charge them up all the way, and they don't drain them all the way. They kind of stay in the middle, and you get the maximum life out of the batteries. But my minimum cell voltage, 3 volts that the wizard set up, and start balancing this, and then within 0.01 volts, and so on. There's my CAN bus settings, I'm set, and there's my net gains all set, ready to go. My add-on settings, this is important because I have 12 thermistors in the system, and the main unit only had 8, so I had to go to a thermistor expansion. So my number of thermistor expansion models, I have 1, but you can have multiples of that. And then I'm enabled on CAN bus 2. So if you dig into the BMS, there's CAN bus 1, CAN bus 2. CAN bus 1 has a termination resistor, 120 ohm, built into it, which I didn't need because, again, as I showed a little while ago, I have termination resistors on either end of my CAN bus, so I don't need that one. So I am on CAN bus number 2, which doesn't have the termination resistor built into the connector. So good to go there. My charge limits. Here's my maximum charge limits. I have a 300 amp maximum charge, discharge, all that good stuff. And that's all set up by the profile wizard. Discharge limits. So one other thing that the BMS does is when you first plug in, if you're down quite a bit on your charge on your battery pack, it'll start putting in amps for the charging, and then you'll go to maximum amps, like right in the middle. In my case, it's a level 2 charger, so my wall charger will go up to 28 amps at 240 volts. So if you do the math, multiply each together, that'll give you wattage. So it'd be about 6,600 watts total. And at the very end, once it hits, I think it's like 85% that's set up in here, then the current starts dropping off, and it may drop off till maybe 5 amps until it gets to fully charged. So again, when you first plug it in, you don't want to hammer the batteries with full current, 28 amps at 6,600 watts coming in. You want to just gradually ease it into that and then ramp up, hit them hard, and then at the end you want to start tapering off until they're charged. So the other thing is my expansion modules. So the other thing is my expansion models. The other thing is take 4. The other thing is my expansion module, my Orion BMS. This is communicating over CAN bus 2, so I had to change the baud rate of that. But here's module 1 right here. And if I edit my settings, I can go into that and I could see here's all of my settings that I have right here set for thermistor 1 to their current temperature is 21 degrees centigrade. The one thing I have is I had a bad thermistor on cell number 9. Thermistor number 9 is open. So the challenge is I've watched some videos where people couldn't get the chargers to work and stuff. This might be a thing to check, is that if there's an open thermistor, maybe a wire issue, not making contact, it's going to show minus 25 degrees. And what that is out of the range, because the profile wizard set up, I can only charge from like 0 degrees centigrade up to 25 degrees centigrade. And anything below that is not going to charge, so your charger is not going to come on. So in this case, I had a bad thermistor here, or bad wire connection. I'll go back and troubleshoot that at some other time. So basically just uncheck the box. When I did that, it started charging. So that's something to look for if you're having some issues, and then basically apply the changes. But I could look at, here's all my temperatures I have right now. Everything's pretty much at 21 degrees centigrade. And once you're done with the profile wizard, what you want to do is you need to send the profile to the charger. Take 2. So once you have your profile wizard done and everything's set the way you want it, you just hit the button here and it sends a profile to the BMS unit. And then if you fire up again down the road, maybe a year from now, you could receive the current profile and then back it up onto, again, a thumb drive, just like you did your motor controller. I could look at my live text data. I could really geek out on this stuff, but diagnose trouble codes, my third-party data. So if I want to connect it to the device, I could do that. And now I'm connected to my Netgain motor controller. And then if I want to disconnect from the device, I'll go onto my Elcon chargers, see what they're doing, connect to the device. And I can see, yeah, I'm not plugged in, I'm not charging or anything right now, so this is all going to be not available. But pretty cool software, very simple to use. You don't have to know CAN commands or anything like that to do this. Live CAN bus traffic, live cell data, like I showed you earlier, histogram and events. You could really geek out on this. But anyway, I'm really enjoying this Orion system. Pretty cool. Go ahead and wrap up. We covered the basically the gauge up on the dashboard, the Xantrex gauge. We covered the BMS unit, programming the Netgain motor with the motor controller inverter. So I think the next thing is to go ahead and wrap it up. There's enough content. I don't want this video going too long. So let's go ahead and wrap it up. Next video, we're going to drive it and button up a couple things that I need to do. Make everything look nice, put some of the wiring and sheathing and stuff. If you have any comments or any questions on any of the stuff I kind of briefly covered, shoot a comment to me. Anything that you see that I did right or did wrong, let me know what your thoughts are. Anyway, please like, share, and subscribe, and thanks for watching.